Splitting the computation of a program into multiple threads might improve performance since we are taking advantage of multiple tasks at the same time. But with this comes increased complexity. We might run into issues like race conditions, where threads are accessing data or resources inconsistently, or deadlocks, which occur when two threads are waiting for each other to finish. Therefore, neither thread finishes. But we will dive into those concepts a little later on in this section, so for now, let's look at how we can create a thread. The first thing we need to do is bring it into scope, which is in standard thread. And now, to create a thread, we just use thread spawn. And then for now, we just want our thread to print out a message. And we'll say hello from a thread. Now let's run this. And we'll see that nothing was printed out, but then we run it again, and hello from a thread was printed out. And then if we run it a third time, nothing was printed out. So why is this happening? Well, it's because the main thread is actually finishing before our thread spawns and is able to print out our message. So what we can do to just make sure that we give our thread time to be created and then print out our message for us, we will use another crate called duration. And what duration is going to do for us is it's going to allow us to make our main thread sleep. So we'll say thread sleep duration from seconds, and then we'll say 1. So we just want our main thread to sleep for 1 second. So now if we run it, we see hello from a thread ran, but then you can also see that there's a little pause, and that pause is our thread sleeping for 1 second. Well, this isn't actually the best way to do this, so there is a better way of doing it, and it is by using the join method. So we can actually delete all of this, and we see that spawn returns a join handle, so we can say let handle equal and then the join handle that gets returned. And now we can say handle dot join dot unwrap. And what join is it's a form of blocking. And blocking a thread means that the thread stops running until the thread represented by the handle join terminates, join handle. So we're going to block our main thread until our thread that we until our join handle that we assigned to handle is finished executing, and that is what join is going to do for us. So now we can say we'll say print line hello from main. And now if we run this, we see that we got hello from thread and then hello from main. So this will always print out prior to this because we told our main thread to wait until this thread has completed its task. So now let's move into a little bit more in-depth threading. So let's create a vector, and we'll just call it v, and we'll assign it the values 1, 2, and 3. And then we want to spawn another thread, and for now we will move this word out of here, and now we want to print out our vector. Well, we see that we get an error. And our error says that our closure, which you can see that we have denoted here, may outlive the current function, but it borrows our vector v, which is owned by the current function. So that word that we originally got rid of, we can now put it back in, and it is called move. And move is going to allow us to force the closure to take ownership of the values it uses. So now if we try to run this, it runs flawlessly because we told our closure to take ownership of the v vector. So now let's look at how we can spawn multiple threads. So we'll keep our current vector, and then we'll create another vector that's going to handle all the threads that we spawn. So I'm going to comment this out since we want to use our v vector again. And now we can say for e element in our v vector, we want thread handles, and we want to push in spawning our vectors in. Now let's just format this to make it look a little better. Alright, so what are we doing here? So we created a new vector called thread handles. And for every element inside our v vector, so 1, 2, and 3, we are going to push in the result. So a join handle, we're going to push in a join handle into our thread handles vector. So what this is going to do, it's going to create 3 vectors for us. And they're going to be running. So while they're running, I want my main function to print main thread. I want our main thread to print out that it's the main thread. And now for handle and thread handles, we need them to join. That way we make sure that they finish executing and print out the thread that they are. So we'll run this, and we see we got main thread, thread 1, 2, 3. And now we see we have main thread, thread 2, thread 1, and thread 3. So the order that you might see may vary differently than mine, but it's a good way to show that certain threads might finish executing not in the order that they were spawned up in. So I just wanted to point that out to you. And this lecture was just a simple demonstration on how to spawn a thread, how to join the threads, and also how to use the move keyword to force a closure to take ownership of the values, because all of this will be important as we continue on learning more about threads as we continue in this section.